Depression is a major mental health condition that affects the way people think, feel, and interact with the world around them. It goes beyond temporary sadness and represents a long-lasting disturbance in emotional balance, motivation, and daily functioning. Because depression influences both mental processes and biological systems, it is now understood as a disorder involving the brain as well as behavior. Recognizing depression as a medical and psychological condition is essential for reducing stigma and for understanding why effective treatment often requires a combination of therapeutic approaches rather than a single solution. Depression is a complex and multifactorial mood disorder marked by persistent low mood, feelings of hopelessness, emotional emptiness, and a significant loss of interest or pleasure in everyday activities. It frequently includes cognitive symptoms such as negative thinking patterns, difficulty concentrating, reduced problem solving ability, and impaired decision making. Physical symptoms are also common, including chronic fatigue, sleep disturbances, appetite changes, and slowed movement or speech. Scientifically, depression is associated with altered neurotransmitter signaling, dysregulated stress response systems, and changes in neural circuits connecting the prefrontal cortex with emotion related brain regions. Genetic predisposition, environmental stressors, and psychological vulnerability interact to shape its onset and course, making depression a highly individualized condition that affects overall quality of life. The symptoms of depression vary widely in severity and duration, ranging from emotional numbness and irritability to social withdrawal and loss of motivation. Its effects extend beyond emotional suffering, negatively influencing academic achievement, work performance, physical health, and interpersonal relationships. Depression may develop gradually or emerge after major life stressors, trauma, or prolonged pressure, and it often follows a recurring pattern. It is among the most common mental health disorders globally, affecting millions of people across all ages and cultures, and represents a significant public health challenge worldwide.
Depression is far more than a simple reaction to a bad day. It is a complex medical condition rooted in a perfect storm of biological and external causes that begins with our genetic blueprint. While there is no single depression gene acting as an on and off switch, research shows that individuals can inherit a genetic vulnerability comparable to a house having a foundation that is more susceptible to damage during an earthquake. This genetic baseline interacts dynamically with environmental triggers, the weather of our lives, which include both acute events like trauma or loss and chronic, low level stresses such as financial strain or social isolation that slowly erode mental resilience. These forces converge in a critical gene environment interaction where external circumstances essentially have the power to activate genetic vulnerabilities. A supportive environment can protect a high risk individual while extreme stress can trigger the condition, even in those with low genetic risk. These external stress physically transforms internal biology by hijacking the body's stress mechanisms, specifically causing the HPA axis to get stuck in the on position and flooding the system with cortisol. This toxic, prolonged exposure to stress hormones creates a profound hormonal imbalance that reshapes the brain and damage areas such responsible for mood regulation, demonstrating that depression is a cascading effect where genetic predisposition, environmental triggers, and physiological changes combine to alter brain function.
Examples of brain regions which are mostly related to depression includes orbitofrontal cortex, which evaluates the value of reward, anterior cingulate cortex and medial prefrontal cortex, which determines the value of actions, amygdala, which does fear conditioning, hippocampus doing memory retrieval, habenula connecting forebrain with midbrain while having functions related to cognition and stress adaptation. Locus ceruleus influencing attention, arousal, cognition, and stress response. Basal ganglia, which is related to reward processing and prediction. The figures you see here shows the brain regions and connections related to depression according to various studies found in literature. Various neuroimaging, brain stimulation, and neuropsychiatric studies were done to explore the involvement of brain regions in depression. However, results of these studies are not enough to accurately localize depression in the brain. Hence, connectivity between these regions and activity of these connections is started to be examined. Nevertheless, results of these studies were heterogeneous and inconsistent due to the variations in brain connections and study designs. Therefore, it is understood that mental processes of depression are complex, unstable, and enigmatic. Studies with more standardized approaches and comparable regions of interest exploring the scattered nature of depression is suggested by literature to understand this subject matter more.
Now, I will focus on the molecular mechanisms of depression, specifically how alterations in neurotransmitter systems contribute to mood dysregulation. One of the most well-known mechanisms involves monoamine neurotransmitters, including serotonin, dopamine, and norepinephrine. Reduced serotonin levels are associated with persistent sadness and emotional instability, while decreased dopamine levels affect motivation and the ability to experience pleasure. Together, these monoamine deficits disrupt communication within brain circuits responsible for mood dysregulation. In contrast, the cholinergic system, which is based on acetylcholine signaling, is often overactive in depression. Increased cholinergic activity is linked to heightened stress sensitivity, negative emotional bias, and depressive mood. An imbalance between monoaminergic and cholinergic systems play an important role in emotional dysregulation. Depression is also associated with an imbalance between glutamate and GABA. Excessive glutamate increases excitatory stress and neurotoxicity, while reduced GABA weakens inhibitory controls in emotional brain circuits. This imbalance contributes to altered neural connectivity and impaired emotional regulation. In addition to neurotransmitters, hormonal dysregulation, particularly involving HPA axis and cortisol, also affects depression. Chronic stress leads to prolonged cortisol release, which negatively influences monoamine signaling and increases vulnerability to inflammatory processes. Importantly, all these neurotransmitter alterations are closely linked to neuroinflammation. Inflammatory processes can reduce monoamine availability, enhance cholinergic activity, and promote glutamate-related toxicity. Together, neurotransmitter imbalance, hormonal dysregulation, and neuroinflammation reshape brain circuits involved in mood, ultimately leading to depressive symptoms.
Depression is not only a psychological condition, but also a disorder involving changes in brain chemistry and neural circuits. Because of this, treatment approaches target both the brain and behavior. First, pharmacological treatments, especially antidepressant medications, are commonly used. These drugs mainly act on monoamine neurotransmitters such as serotonin, dopamine, and norepinephrine. In depression, the signaling of these neurotransmitters is often disrupted. Antidepressants help restore their balance in synapses, which improves communication between brain regions involved in mood regulation, such as the prefrontal cortex and limbic system. Another important treatment option is psychotherapy, particularly cognitive behavioral therapy. While psychotherapy does not directly change neurotransmitter levels like medications do, it leads to functional and structural changes in the brain. Studies show that therapy can strengthen prefrontal cortex activity, improve emotional regulation, and promote neuroplasticity, which means the brain's ability to reorganize and form healthier neural connections. Lifestyle changes such as regular sleep, physical activity, and stress management are also important supportive treatments. These behaviors can positively affect brain chemistry and neuroplasticity, helping to improve mood and enhance the effectiveness of therapy and medication. In recent years, newer treatment methods have gained attention. One of these is ketamine, which works very differently from traditional antidepressants. Ketamine acts on the glutamate system, especially the NMDA receptors, and can rapidly increase synaptic plasticity. This is why ketamine can reduce depressive symptoms within hours or days, especially in treatment-resistant depression. Another modern technique is transcranial magnetic stimulation or TMS. TMS uses magnetic pulses to stimulate specific brain regions, usually the dorsolateral prefrontal cortex, which shows reduced activity in depression by modulating neural circuits involved in mood and cognition. TMS helps normalize brain activity without medication.
To wrap everything up, the main message of our presentation is that depression is best understood as a condition involving brain networks and connectivity rather than one single depressing center. Many studies point to the involvement of several regions such as the orbitomedial prefrontal cortex, anterior cingulate cortex, amygdala, hippocampus, nucleus accumbens, habenula, locus coeruleus, cerebellum, and basal ganglia. At the same time, results don't always look identical across different studies or different individuals. So instead of focusing on one fixed location, it makes more sense to think about how these regions work together as an interacting system. With their network perspective in mind, another important point is that depression usually develops through more than one influence happening at once. Genetic vulnerability can increase risk, and then environment factors and stressful experiences can shape how that risk shows up over time. When stress becomes long-lasting, it can also affect the body's stress response systems and contribute to hormonal dysregulation, which can influence brain circuits involved in mood and emotion. Then at the molecular level, we discussed how mood regulation depends on several signaling systems staying in balance. Changes in serotonin, dopamine, and norepinephrine can influence emotional stability, motivation, and alertness. But it doesn't stop there. Other systems matter too. Shifts in acetylcholine activity and changes in the balance between glutamate and GABA can affect how stable and well-regulated emotional brain circuits are. And these neurochemical and hormonal changes are often discussed alongside inflammatory processes, which may further impact neurotransmitter function and overall neural communication. If we connect this to symptoms, the picture becomes more intuitive. When someone experiences low motivation or loss of pleasure, that can be understood in relation to reward-related circuits. When negative mood and emotional reactivity become persistent, that can reflect changes in how emotion-generating and emotion-regulating regions interact. And when sleep, energy, or attention shifts, it can be linked to disruptions in systems that support arousal and control. In other words, symptoms are not random. They can reflect changes in coordinated brain functions. Most importantly, this also leads to a hopeful conclusion. Depression is treatable. Standard approaches include psychotherapy such as CBT and interpersonal therapy, and medications like SSRIs and SNRIs. Supportive lifestyle strategies like improving sleep, staying physically active, and managing stress can strengthen recovery, and for some people, advanced options such as ketamine, esketamine, and TMS may be used alongside other treatments. Above all, it's important to remember that depression is a medical condition, not a personal failure. Building awareness and reducing stigma helps people feel safer seeking support. If you notice these symptoms in yourself or in someone close to you, reaching out to a mental health professional can be a strong and valuable first step. As a final step, here are the key scientific sources we relied on throughout the video, and thank you for listening to us.